Persze, nyugodtan, ahogy kényelmesen.
Így jó lesz, nem? Hát így
Nem tudtam, hogy ide kell.
Szép választási lehetőség.
Van, minden van. Hát akkor vegyem majd ki a mikrofont, azt mondjátok.
Igen.
Is kell venni?
Jó.
Akkor elkezdem.
Figyelj meg, Júli, az Anna itt.
Distinguished guests, ladies and gentlemen, I would like to warmly welcome all of you, the experts of natural hazards and climate change research. This is the second conference in this very important topic in Szeged. I would like to introduce the representatives of the organizer, the University of Szeged. First, Professor Edith Paulik, the head of the Department of Public Health, Albert Szent-Györgyi Medical School of University of Szeged. Professor Dezső Horváth, the Dean of the Faculty of Science and Informatics. And at last but not least, Professor György Sipos, the head of the Department of Physical and Environmental Geography. The first conference was held 2 years ago in 2023, and due to its success, the organizers decided to repeat the event, and who knows, this might be the start of a conference series. The topics are hot, my time is short, so it's better if I hand over the microphone to our highly esteemed university representatives. First of all, I would like to invite Professor Horváth to give his speech.
So first of all, I would like to welcome you here in Szeged in this conference. As we heard, the topic is hot. I would say important. And there are many important topics, and this one is a little bit different. First of all, it's multidisciplinary, that we understand, but many people may not. I approach it from a different angle. I have a degree in chemistry. And so for me, precipitation means something different than for most of you. But that's okay, because most of the public know nothing about chemistry. But these topics are areas that a lot of people think that they know what's going on, or at least they have opinion. And we know people usually have opinion about things they do not know. So you, in this field, have a responsibility of educating the public. So by doing research and exchanging knowledge, because you may come from different areas, and both natural hazards and climate change are important for us. And the importance comes from its difficulty that, as a scientist I say, we have basically two time scales, a long range, very long time scale, and a short time scales. And the interaction of these, that make it very difficult what happens. For most people, let's say, whatever happens outside, far from humanity, far from mankind, we take it as granted. It is what it is, and it will not change. But because of the long time ranges, things do change. And these two changes will bring about changes on the small time scale. Because of this time scale, I would like to quote a joke from Kelvin and Hobbes, that he was not an eminent student, Kelvin, when he had to write a test. And the question was, what is the importance of the Yalta Conference during the Second World War? And the answer was, considering the motion of tectonic plates, nothing. So the important here is, again, that we, on a human life, we think about 10 years, and doctoral project lasts no more than 5 years, but most of you will study things that happen on a much longer time scales, and they will be very important. So both climate change and the national hazards are important. And so I'm happy that this is not the first conference, so hopefully it will continue on, because this is now the second time. Szeged is the city of sunshine. Yeah, cloudy, but the sun is still here, don't worry about the clouds. So, but at least you stay inside and enjoy the conference and exchange ideas. So again, on behalf of the Faculty of Science and Informatics, I wish you very good discussions and a fruitful conference. Thank you.
Thank you very much, Mr. Dean, and I would like to invite Professor Edith Paulik to give his speech.
Okay. Thank you. So, dear guests and colleagues and organizers, Dean of the faculty. So I welcome everybody, all the participants of the second Natural Hazards and Climate Change Conference on behalf of the leadership of the Albert Szent-Györgyi Medical Faculty Medical School of the University of Szeged. As everybody knows, the natural hazards and climate change are very complex, interconnected issues that require an input from many fields, such climate science, public health, medical care, emergency care, engineering. We know, everybody, but especially from the point of me as a public health professional and physician, that the threats from the point of the climate change is very complex, and we detect the physical, mental, and social well-being related problems in the society. We know a lot about the health effects of climate change, especially from the point of us. The pregnancy-related problems are very important because we have a lot of data, more and more data about the relationship between the climate change effects and the increasing number of or increasing risk of the preterm births. And on the other hand, we see a lot of health problems in other vulnerable populations, like in old people. So I think that the collaboration between the environmental and medical services is a very important point from the point of our future in the whole world. Because maybe here more environmental scientists than physicians, but the environmental scientists help us to understand the hazards like the floods or the heat waves. But on the other hand, the medical scientists assess and manage the health consequences. So as I see the program, there are a lot of lectures, poster sessions, and interactive workshops. And I'm hoping that these platforms will bring together the scientists, the practitioners, and we will share our knowledge, the best practices, and other innovative solutions. And finally, it will be a very successful discussion about the problem, and on one hand, and on the other hand, I am hoping that this interdisciplinary platform will initiate further collaborations and further results, national, international level. So thank you for being here, and thank you for the organizers inviting me and our department to participate, and I would like to wish you a successful conference. So thank you for your attention.
Thank you very much. And then finally, I would like to ask Mr. György Sipos, Professor György Sipos, to say some useful words about the event and the program.
Thank you very much. So I'm talking, first of all, on behalf of the organizers. And I really would like to thank you that you are here with us, and welcome everybody, especially those who are coming from very far, several hundreds of kilometers, even somebody several thousands of kilometers. So that makes us our conference really an international one, which we are very proud of. And as it was mentioned, this is the second. And actually, when we finished with the first, we thought, oh, we will not do anymore because it was so demanding. But you know, memory and public memory is also an important thing in terms of climate change. So our memory is short. So after 1 year, we decided to organize another conference, and especially because, and I would like now to underline our funding, which cannot be seen here. I don't know why. Yes. No problem. So on the slide, there's a logo. That's important, I tell it for the camera. Because we were founded by the National Research and Development Agency, under the Mezzonatura program, but that's only the let's say the commercial part. What I would like to say that really this is a very interdisciplinary conference. We are very proud of that, and we are very grateful for the Institute of Public Health, of course, to help in the organization, and also the Department of Ecology. They helped also a lot in the organization. And I will not finish saying thank you, because I would like to thank my colleagues who helped a lot in organizing this conference, because without people, we would be worth nothing, of course. Some technical information I would like to say in terms of the program, for example. We sent you a lot of emails, and my colleague said in the end, let's not send so many emails because you will not check them. So I tell you the most important thing, that on your phone, if you open the conference homepage, nethas.eu, you will find all the abstracts selected into or classified into the sessions. So if you go there, you can see at each session a blue button, and you can see the abstracts there. So you can also check these during the sessions. That's very important. Another thing is that in the folder, in the back of the folder, you will find a map. Okay, so this map shows all the places that are important. Actually, this conference was planned to be held at our institute, but our institute is under renovation, so we moved here to the Szeged branch of Academy. And on this map, you can find everything. There's only one modification, but I will tell you that tomorrow. You don't need to care about that. Here is the place where we will have the lunch. Here is the place where we will have the dinner. And of course, the place of icebreaker, but the icebreaker is over, so you don't need to go there again. All right. My colleagues told me to tell you this is a very, very, very technical information. Toilets are that way on the main, okay? Because it's very hard to find them, but and finally, I just would like to show you an opportunity, because of course our conference cannot be seen from space, but it's on the radar of publishers. So I got an invitation to make a special issue, and I would like to ask you in the breaks or during lunch or either during dinner, please approach me if you are interested, because based on that we can make a special issue in a new series of Springer Nature. So I think the journal is highly respected, so it's a good journal. But of course we have to decide, or I have to decide, or the scientific committee has to decide, not me, of course, what's going to be the topic. So if most of the topics are coming from geo, then there's a geo topic for the special issue. If most of the topics are coming from environment or ecology, then we try to do the special issue in that way. So it's now under formation, of course, but I think it's a good opportunity for our community, for the Central Eastern European community, or even beyond, to show us in a highly ranked issue of Springer Nature. Okay, so that was my part, I think, and technical information will be given to you, I think, regularly, because in a conference there are always some changes, and now we are also in some, let's say, delay in terms of our plenary speakers because of train issues. So we will now have a small break, and I do hope we can start according to the schedule at 10:30, but maybe there will be a little bit more break. We will see, but I will go around. Don't go away. That's the point, because they will arrive. Maybe we will have a little bit delay in the starting of the program, but I do hope that everything will be nice and fluent during the day, and I do hope that you will enjoy Szeged. Don't forget that this is a wine festival season. Okay. Now climate is changing, and we never know what happens in the summer, but there is one certain thing. When there's a wine festival in Szeged, at least 3 or 4 days are rainy. So this thing is coming now as well. The rain is not so heavy, so with the help of our conference and with the help of the wine festival, we can survive probably. So please enjoy the time here. If you have any problems, just look for us. We try to help you, and that's all. Thank you.
Thank you very much. So not just climate changing, that's the program too, and we have to organize more often the wine festival if there is no enough rain. Thank you very much.
All right, we try to start at 10:30, of course. So don't go far. And let's hope the best.
Mindig egy online meeting minden 10 órára, de 17 perces megyek egy online meeting.
Hát ide jössz, és akkor föltesszük. Zárjuk be. Bedugod? Aha, jó, nagyon jó. Jó. Ide tegyem, ide tehetem?
Akar még valaki, akkor ide.
Jó.
Annak késik az.
Igen, úgyhogy
Akkor kell a...
egyel későbbi vonatra ült föl,
Igen?
és 10-15
Nem jött el a volna? Ja.
Nekem így mondta, hogy egyel későbbire ült föl, hát lehet, hogy
Ja, én meg azt hittem, hogy annyit késik, mert azon se repülték.
azon se egyébként. Azt mondja, hogy ezt kihúzom ide előre, nem rakom be a szekciókba, hanem ide kiteszem is.
És akkor itt nem kell, hát innen a pluszok, vagy innen kell beszélni, ugye?
Persze.
Nem kell mozogni meg sem.
Nem. Annyi, hogy léptető is, és akkor ez nem laserpointer van, hanem ilyen...
Tudom miért, nem szerolom egyébként, de mindegy.
Tehát ahogy jól esik természetesen. Csak oké.
És akkor 35 perc.
Hát 30.
30.
Na, hol vagy? Itt vagy.
Félkor kezdünk, vagy?
Igen, akkor elkezdjük félkor. Nem tudtam, most azt mondtam a többieknek, hogy nem tudjuk még mikor van kezdés, de megérkeztél legalább akkor te is, akkor így tudunk kezdeni.
Hát én úgy terveztem, hogy így a megnyitó körül, aztán mondom, megálltam ahol vagy egyet kávézni, mert mondom, olyan messze vagy, ez hosszú az út, meg
Jó.
el kellett menni.
Foglalj addig helyet, jövök, megyek, jó? Ne haragudj.
Persze, csinálj csak a dolgodat.
Okay, dear participants, good news. We can keep the time, so we will start at 10:30 according to the schedule.
technical member helped me. So welcome everybody in Szeged. Let me introduce just a short introduction for the first lecturer in the plenary session. Professor Dr. András Gelencsér. He's an atmospheric chemist of University of Pannonia, full member of the Hungarian Academy of Sciences, where he's the head of the Air Chemistry Research Group. Dear Professor, please keep your presentation.
Thank you very much for the introduction and for the invitation to be the speaker of this conference. And I will start the presentation because the other speaker is still on the train, so she's coming. So we just changed the order of presentations. And I will talk about green transition, and I will present some challenging ideas about global green transition, and I will always speak globally. So I would not speak about European or Hungarian or whatever countries and the world, but just how green transition takes place in the world. But before going into details, I would like to pinpoint the structure of the world, how it is operating today. So global problems are everywhere. So we are living in the era of ecological crisis or polycrisis. And normally this is taking place in the reality. So we need science in order to get some knowledge about the background and the causes, root causes of these global problems. And we need to work out together real solutions that work in reality. In reality, nature's laws are always on, so all laws are active. But there is now an alternative realm of politicians and the public. This is called alternative truth. This term is coined by Donald Trump. And this alternative truth is a favorite playground of politicians. They like to be here. This realm is characterized by the fact that nature's laws are turned off, so they are not valid in this realm. So everything can be done in this sphere. And of course, when we have some problems, we have some preliminary knowledge about the causes of these problems, but these are too complex to be understood by politicians and by people, by the public. So politicians often fabricate a kind of one-bit message of these global problems, very simple messages that can be communicated and can be understood by the public. And when it is associated with some business interest, which is usually the case, you actually lead to virtual solutions which do not work in reality. I just quoted the bullshit. And that has nothing to do with real solutions, so it's just some fancy term that can be used for business purposes. So this is more like a marketing message. And unfortunately, many global problems fall in these categories, so are solved by politicians this way, without any concern on the nature's law or realities. So that's how the world works, and especially in the era of internet, this sphere is really grown very rapidly, and it's just kind of dominating the world. So, and in this realm, everything is really possible. So there is no constraints for imagination. So you can do everything. And one of these messages in terms of climate change, which is of course one of the most threatening crisis for humanity, also globally, there is this very simple idea that climate change can be fixed. Like a tap, a dripping tap, or anything, or a broken car, we can fix climate change. So that's a brave idea from us, that we can somehow fix the climate. There are many ideas along this way. And this idea is represented by the International Panel on Climate Change, which is a kind of international body on the issues regarding global climate change. And this figure is from its report from 2023, so 2 years ago. They issued a report, and you can download this report and you can find this figure there. Actually, this figure shows the kind of roadmap to green transition, which means that we have emission of carbon dioxide, or more precisely, carbon dioxide equivalent, which is shown by the black curve, showing the real emissions from the year 2000. And then follows this ideal roadmaps how to curb global climate or global temperature below a certain threshold value. And the endeavor of humanity is still the limiting warming below 1.5 degrees centigrade, which is already in the review mirror, because we are just very close to just exceeding this theoretical or visual limit. But so we are increasing our emission since the Industrial Revolution, but now we are very determined, at least in theory, to go back and to kind of zero or net emission within a few decades. So that's a very brave idea, really a very promising one, and at least in the theoretical, in this fairy tale world. And which is interesting in this figure is that reality is represented by the black line here, and the report is from 2023, but the reality ends at the year of the Paris Climate Agreement in 2015. So 8 years are missing from the reality, which are just overlooked by this figure, which means that they do not want to show disturbing figures for thinking. So they would like you to see how to move to zero carbon emission, in spite of the fact that our emissions are still growing. So I just come to this very simple idea of green transition. This is on a global scale, that we have to keep economic growth, because this is in the core of all countries' policy. So economic growth is unquestionable, so they need to keep it in any case. And then when we perform this green transition, which roadmap was shown in the previous slide, and in addition, we also progress in digitalization, introduction of artificial intelligence and the like. And these together will bring us some very bright future, like sustainable, green, smart, whatever. So people will live in unimaginable being. So every of us will be very happy with that. And this is the simplified concept of this very simple one-bit illusion is shown on the left panel in the form of a kind of infographic. This is the concept of Disney tales, fairy tales. Actually, there's a bad guy, the fossil industry and all these equipment using fossil fuels, and the good guys are the renewables and electric cars and the like. And when we replace these fossil equipment with renewables, each problem of humanity will be solved and we will live in happiness forever. So that's the concept that is behind this green transition. That's a very good business model. So it will really boost GDP in all countries if you make this transition. You replace the whole infrastructure, energy infrastructure, and all other infrastructure within 2 decades. That's a very good business. So it's a very nice marketing idea to declare this decarbonization. But let's have a look at what the effect will be for climate. This is again from this report, actually from the scientific report of the IPCC, showing all these atmospheric constituents that play a role in climate change, and the size of these columns show the impact of the given atmospheric constituents or the contribution of these constituents to climate change. And if you see these, if you just look at this diagram on the left, you see that carbon dioxide is an important contributor to climate change, but not the only one. So if you remove carbon from the equation, then you still have a lot more. So eventually, if you add all these columns together and calculate how much carbon is responsible for climate change, you end up with some 30% of the overall effects of anthropogenic activities to or changing climate. So if you remove carbon dioxide, you would not stop climate change in any way. So that's from the report. So that very simple concept of decarbonization does not follow from this graph of the same report. So that's some kind of cognitive dissonance, that we have knowledge on the causes of climate change, but still we declare that if we stop CO2 emission, every problem of climate will be solved, which is not the case. And I would like to remind you another atmospheric constituent, this sulfur dioxide, which has an opposite effect to greenhouse gases. This is actually cooling the planet. These are the case for large volcanic eruptions, which cool the planet due to emission of particulates and increasing albedo of the Earth. And unfortunately, SO2, sulfur dioxide, also comes from the very same source as carbon dioxide, namely the combustion of fossil fuels. So if you stop combusting fossil fuels, you stop CO2 emissions, but you also stop SO2 emission to almost level off. So you have nothing actually, or very little, when you make this whole change of green transition. So that's very simple. You can just look for yourself from this from the report of the IPCC. Yet it does not disturb politicians to declare that CO2 is the culprit and you need to get rid of, and then you will stop global warming, which is simply not true. And there is another misconcept of climate change, that we need to stop climate change under 1.5 degrees centigrade relative to pre-industrial level. The common misconcept is that above this critical threshold, different very strong feedback processes will just switch on and will start to be in operation, which active from 1.5 degrees centigrade onwards are actually have been active for decades already. One example is the depletion of sea ice in the Arctic, which has been in a rapid decline for more than 4 decades, actually. And actually 70% of the volume of the sea ice has been lost for the last 4 decades already without reaching global mean temperature of 1.5. So that's not true that nature works in a very simplistic way, that waiting for 1.5 degrees and all these processes are waiting, okay, 1.5 degrees, so we start to work. That's not true. So all these processes are already underway, and they are already contributing to the energy balance of the Earth, actually to climate change. So let's have a look at how decarbonization is taking place globally. You have plenty of data on that. You have a report each year issued by the Energy Institute about energy use, global energy use from the past year. And when you have a look at this report, you see that we have the global decarbonization from 1992. Actually, that was the year of the very first climate summit, which was the Rio conference in 1992, and that was the place and the time when the humanity decided to get rid of fossil fuel and start to reduce their emission of CO2. Actually, that's more than 30 years already. But since then, CO2 emissions are up by 67%, so that's not the direction that we declare to take. Actually, it's the opposite. So we are not heading for decarbonization, we are heading for adding more CO2 to the atmosphere. That's globally. And there is another indicator of our success, which is the share of fossil fuel to the global energy mix, and it was 82% last year. So all the energy used by the world last year, 82% of it was actually some sort of fossil fuel, and only the rest was something else. And that in 1980, when there were no decarbonization, no green transition, nothing, not even mentioned in global politics, this ratio was 85%. So we are down by 3% over a course of 40 years. That's not it's not a great success story anyway. What's the cause of missing this target or not taking this green transition globally? So as I mentioned, this very simple concept is based on replacement of fossil fuels by renewables. But if you consider the potential of renewables, and you need to set up nominal capacities of these different renewable energy production methods, then you end up with a diagram like this. So 1 terawatt is diagram. So if you really want to install these capacities or manufacture these capacities and install them, then you need a lot of materials because of the very low energy density. So if you have a solar, for example, you need a huge number of masses of all these bulk materials like copper, concrete, glass, steel, aluminum, and the like. And this is only for nominal capacities. And as you know, all these energy production methods are intermittent. They are not, they have a very low utilization rate over the course of a year. In Hungary, for example, solar photovoltaics have an efficiency of 14%, 14% relative to their nominal capacity. So you should multiply these columns by 7 if you want to have it normalized to the energy total amount of energy produced. So 7 is in the roof. So that's very big numbers. And these are bulk materials which are very energy intensive. So all these concrete production and steel production are really very energy intensive. And that's, for them, there are not a single decarbonized solution. I mean, industrial production has no large scale or industrial scale decarbonized or electrified solution. If you consider these the big four, the steel, cement, plastic, and fertilizer production, that four account for 25%, 1/4 of all energy used by the world. These four big industries cover one-fourth of the global energy use, and there is not a single factory, not a single plant in the world that are not using fossil fuels. And also there are other sectors like services, like shipping, global shipping, aviation. There is not a single large-scale or military. That's not a single one. If any of you can show me a single industrial-scale facility anywhere in the world, he or she will receive some champagne, like Dom Perignon, a box of Dom Perignon immediately. Nobody ever even tried to name any, because there isn't any in the world. So that's a problem. And altogether make up 50%, half of the energy used by the world, and there is not a single decarbonized solution since 1992, when the world decided to get rid of the fossil fuels. So there is no solution yet for more than 30 years. But if you look at the media has very fancy things every week or every day, and they already have the solutions. But these solutions are in the realm of the alternative truth, not in reality. So we see the examples here, headlines from the media, like electric cargo ship looking very smart, and the electric plane also on the other side. And these look really very fancy, and the date, I mean, the date of the report is last year. So we started decarbonization in 1992, and we came out with the very first electric cargo ship 40 years later or 30 years later. So that's not a big progress anyway. And the airplane is similar, like 2022 or something, last year or before that. So we are not in a hurry in decarbonizing these very energy-intensive sectors. But if you look at the capabilities of these fancy and nice-looking stuff, it can carry only 700 containers, cargo containers. A cargo ship can carry some 20,000, over 20,000. I mean a real one, not this toy like this. And with a single battery charge, it can travel only something over 300 kilometers. And in addition, it cannot go out to sea. So it can only go back and forth in rivers or lakes. It's not allowed to go out because its battery does not contain enough energy to withstand the currents and all these strong winds out the sea. So that's a toy. That's not a solution, not a real solution for this energy-intensive sector. And for the plane, that's not a Boeing, not an Airbus. 9 passengers and 800 kilometers. That's not an alternative to global aviation anyway. That's just some nice toy for some rich kids, but that's nothing. So that's electric aviation. That's nowhere. These are hyped very much in the media. So you find every second week you find some similar stuff without going into details of capabilities, that everything is solved, everything is invented, and it's on the right way. So, and that same holds for batteries, which are in the forefront of green transition, like electrification. We need batteries. And if you read the newspapers and the media, then you find every week revolution in the battery industry. British scientists invented very smart things which are just at the brink of being commercialized. Breakthrough, revolution everywhere. And the headlines are full of these hypes. But what is in reality? Let's have a look at that. Batteries are not new, despite that they are communicated as something being part of the 21st century. Actually, they were invented in the 19th century, in the middle of 19th century, and the first battery was a lead-acid battery constructed in 1859, and its energy density. Energy density is the most critical parameter of batteries, how much energy they can store in unit weight or volume. And it was 40 watt-hour per kilogram. That was the energy density of this lead-acid battery. And today's lithium-ion batteries, which are representing the cutting edge of commercial batteries, have an energy density of about 6 times as much, some 240 watt-hours per kilogram. So it's a factor of 6, 150 years. So that's revolution or not, you can decide. But the problem that we need to replace we want to replace fossil fuels. And fossil fuels have energy densities of 12,000 watt-hour per kilogram, which make them available for many applications like shipping, aviation, whatever. So they are very energy dense. Originally, the energy content of fossil fuels are given in megajoule per kilogram, so not in watt-hour, but you can just convert one unit to another. They both are energy units. You can make calculations, and you end up with a number that is 60 times as much as the energy density of the best performing electric batteries. So that's why there are no aviation solution, no cargo shipping, electrification of all these sectors, because the energy density of even the best performing batteries are painfully low. So there is no real option. All the revolution in battery research and industry is taking place in the red circle around zero. So there is no, even solid state batteries, which are not yet commercialized, have an energy density of 400 watt-hour, which is a far cry from the energy density of fossil fuels. And even in these alternative fuels, you cannot imagine, for example, airplanes going with a cable above and then like a trolley or trams over the ocean, so that would be the only solution if they do not need to carry electric energy or chemical energy with them, but can take the energy from en route. So that's not possible for many sectors to have such a solution. So that's the problem for the battery and for the electrification. There are very serious physical constraints ahead of electrification. And here comes the other wonder solution in the alternative world. This is actually the hydrogen, which has been reinvented quite recently. even it has color already, because when I studied chemistry, I learned that hydrogen is a colorless gas. But no, it already has color, like green. And then this is another revolutionary solution to all the residual problems of humanity. So it is actually reinvented. It is one of the best known elements in chemistry, at least. So we know everything about hydrogen. There is no surprise. It's in its property, all these details are have been known for 200 years about hydrogen, and it would not change. So, but now it is reinvented to decarbonize many sectors. But the problem with hydrogen, with green hydrogen, there is one single problem, actually, that it doesn't exist. Hydrogen doesn't exist on Earth as available directly to produce energy. It exists in its compounds like water or whatever. So you need to produce hydrogen first. And in order to produce hydrogen, you need to invest energy, usually more energy than is available when utilizing this hydrogen. So if you follow this cascade of how green hydrogen is used for energy storage, actually, hydrogen is not an energy source, actually, it's an energy storage method, a kind of battery, storing energy, electric energy in the form of chemical energy. So it's like a battery, but its efficiency is very low because you need to go through all these steps, produce hydrogen, store it, and revert it or convert it back to electricity. And if you take into account the efficiencies of each step, which are limited by thermodynamical constraints, and you multiply these efficiency numbers, you end up with an overall efficiency of about 30%. So the hydrogen is not an energy source, it's an energy storage method, and it has an overall efficiency of about 30%, meaning that 70% of electric energy is lost. So you are making all these fancy cascade of hydrogen and you lose 70% of primary energy. That's not a good business anyway. So it would not revolutionize the world, only in the media hypes. It's solution to everything, but in reality it's practically non-existent as a large-scale solution. It's already in use, not for energy storage, that's very little, but for industrial applications like fertilizer industry using hydrogen for ammonia synthesis, or oil industry also uses hydrogen for reforming fuels. And globally, about 100 million tons of hydrogen is used each year. And out of these 100 million tons, only 0.1% is green, is produced from water. And the rest is still produced from gas, natural gas, or coal, because of the energy requirement of the production, because oxygen and the bonds, chemical bonds between oxygen and hydrogen are much stronger than the bonds between carbon and hydrogen. And that means that for producing hydrogen, we need 3 times as much energy if we use water than when we use natural gas, so that no companies are doing this. Nowhere in the world. So they are not producing hydrogen from water, they are producing from natural gas. All the companies in Hungary as well, like PET, the nitrogen fertilizer plant, are using natural gas. MOL is also using, the oil company also using natural gas, because it's cheaper. So nobody's doing that. The technology is there, so you can do it anytime. You can do it for 70 years already. After the Second World War, the technology was already worked out and ready to use, but nobody actually is using it. Okay, and then there are solutions like geoengineering, which are really very fancy. There are a number of such studies how we can modify the climate by doing different stuff, different things. And this is my personal favorite, actually. This is actually from Science. This is from a paper that appeared in Science last fall. And it was committed or written by Swiss scientists from ETH Zurich, which is one of the top universities of the world. And they are producing this idea of injecting 5 million tons of diamond into the sky, into the stratosphere each year in order to stop global warming. And this is a science paper. So I feel ashamed as a scientist for doing such bullshit and publish it in the top scientific journal by top scientists. So the world is really crazy that doing so absurd stuff like this. You can read this paper in Science. 5 million tons of diamond powder to the stratosphere each year to produce some 10,000 tons of industrial diamond over the course of history. And we plan to inject 5 million tons each year dispersed in the stratosphere. That's something which is absolutely crazy. I just put it there, no comment. So what's about this green transition ahead of us if we just neglect facts and neglect constraints of nature and physical laws, like politicians always do? So if we follow this course, then we will not end up with some very happy, sustainable, green, smart, whatever future, but we will have a brutal resource crisis because we will use up our remaining resources, especially material resources, because they are also being depleted, not only fossil fuels, but all mineral resources and others are just being depleted all the time. So we will face a brutal resource crisis, and we may induce the collapse of modern civilization if we run out of something which is essential for keeping our civilization working. And this is because we still pursue economic growth. So economic growth is about all. So we do not even question the necessity of growing economy, GDP, whatever. So if you keep this, you will end up with some very brutal consequences of economic and societal collapse due to this very much forced and unrealistic policy that are taken by the world. And that's the problem. That's not about Europe, about any countries. This is a world program to decarbonize with these constraints being neglected. So that's a real problem. There is a saying from Aldous Huxley that facts do not cease to exist because they are ignored. But that I would just recommend to the politicians that they should take care of reality, all these physical laws and nature's laws, and do not pursue all these dreams which are not based on reality, because eventually reality will win when we just run into the constraints of our modern worlds, like these material worlds. So with that, I would like to thank you for your attention, and if you have any suggestion for solution, that it's more than welcome. And if you have questions, or if you want to challenge any of my statement, that please come forward and do so. Or if you want to receive this Bon Perignon, then you can suggest some existing solution to all these problems that I just outlined. So the floor is yours. Thank you.
Thank you for this interesting presentation. And we try to keep the time sharply, but maybe I can offer you, maybe take one question, and the next question we can come, for instance, in the coffee break. But please, if you would like to take up one question, we can have it. Okay.
No applicant for the Basel. Yes.
I like it very much. It's very simple.
Yeah.
You mentioned. Do you think that if we take a focus on the local values, the variation would be high enough to give us some still promising result? Because variation or fluctuation, spatial temporal, is very important.
No, the problem is global, actually. For example, climate change is global. There is no climate for Norway or for Liechtenstein or for Hungary. Climate is for the globe. And all these problems can only be solved on a global level. So it cannot be solved locally, because what only matters is actually what happens on a global scale. If you have some success achieving some decarbonization in some country, it would not count in a global equation. So actually, we need global cooperation, which we do not see these days. That all these problems can only be solved on a global level. These local successes, like in Norway, they just announced that they reached some level of decarbonization, doesn't count, because all the rest actually of their activities are left in the global south. So they left all these mines, all these activities, heavy industry in India, in China, wherever. So if you are green here, but you have all your other impacts in other countries. So and also you transfer your waste to the global south. So that's not being green. It's just kind of green hype for some countries in order to get some attention and politicians to declare some success, but it doesn't actually change the course of global problems. Okay.
Thank you very much. And yes, nagyon röviden felvezetem közben, jó? De és akkor közben be tudja tölteni. Úgy van. És szerintem ott látni is fogja.
Elég bonyolult ezt itt megtalálni.
Közben beszélek egy kicsit, jó? Felvezetem.
Egy kicsit ilyen azt mondja, hogy és itt kell lenni egy ilyennek, hogy itt Szeged, ez az. Oké.
Jó is lesz, és akkor...
Igen.
Okay, so our next lecturer, next presenter is Dr. Anna Paldi, specialist of public health and epidemiology, and deputy director of the National Center for Public Health. Her team, among others, developed and introduced the 3-stage heat alert in Hungary. Please, Madam, keep your presentation.
Yeah. Thank you very much. Sorry for being a little bit late, but I think this change of the program was very, very useful, because Professor Gelencsér gave us a very nice overview of the nice future, in quotation mark. So we should think about the future very seriously, and we will see that we have already see the impact of climate change. So what is our task? To do every kind of measures and every actions in order to be adapted for this very, very sore future. So my topic of my presentation is heat waves. And as every lecturer, I also start my presentation just recalling the IPCC reports. And several reports have already stated that the climate change has a catastrophic impact on the life of millions. And as we can see, the climate change related deaths are increasing. And there's also a need to reduce the way or the speed of the global warming. So we have decided to keep the global warming at a level of 1.2 degrees of centigrade. But as you can see, the Copernicus report of the previous year, 2020 and 27, has stated that that was the first year when the temperature increase on global level already exceeded the desired 1.5 degrees of centigrade. So that is the very brief future overview. And now let's see what kind of health impacts are threatening our health. So there are direct health impacts and indirect health impacts, and they are strongly mediated by the environmental circumstances, social circumstances, and public health determinants. And we have to keep in mind that between 2030 and 2050, climate change is expected to cause approximately 250,000 additional deaths per year. And what are the causes? This is malnutrition, malaria, diarrhea, and heat stress. So when I just point out to malnutrition and malaria, that regards the global level. For Europe, the major problem is, first of all, heat stress. As the fact sheet of the IPCC stated, key one risk is the increased heat-related mortality and morbidity of people and changes in the ecosystem due to heat. There are also others very significant climate change drivers like natural disasters as the consequence of extreme heat, including droughts, bushfires, and flooding. And we also have to mention that as the frequency of heat wave rises, the water availability and the sea level rise will also display a great threat. So who is at the greatest risk for heat-related illnesses? So of course we know that elderly, first of all, elderly people, then those who have chronic diseases, and the young babies, infants and young babies, and also pregnant women. So they are at the highest risk. But if you look at this very nice slide, we can see that there's some hope that if we are doing some kind of measures to reduce the risk and increase the way of potential adaptation, then the risk of the certain hazards can be reduced. And you can see what are the most important parts, most ways of adaptation which can reduce undernutrition, heat-related mortality and morbidity, food and waterborne diseases, infections, vector-borne diseases, and so on and so on. So there is some hope that in the near and far future we can a little bit reduce these impacts. So if you look at this picture, then again we can see some evidences of the highest global average temperatures, and as you can see at the end of the slide, I hope. Oh no, it's. I wanted to show, but. Is that? No. So it doesn't. Seems that it does not work. So you can see that there were some very, very high temperature extremes, and as you can see, the last column shows us that July the 22nd in 2024 was a very, very critical day for the global temperature. The daily average temperature at global level was 17.16 degrees of Celsius, which is, as you can see, it is an extreme increase. So it means that there are some parts and some days when the temperature increases to a very, very dangerous extent. And if you look at the European situation, the situation is very, very similar. So you can see that there is an increase, and we can see that around the beginning of the 21st century, this increase started. And of course, there is some kind of variation, but from 2015, you can see an almost continuous increase. We don't know yet what will come this year because the weather variabilities can be seen right now. And again, I can show you a longer time series of temperature, and as you can see that in 1970 this process started in these years, and the increase is very steep. And as you can see, that again, it is indicated that the last year was a critical year for the exceed of the threshold. And if you look at the Hungarian situation, the situation is quite similar or even worse, because the last years, as you can see from the graph, the temperature increase was much higher. And even in the last years, we surpassed the increase of 2 degrees of centigrade. So the speed of the increase of temperature is even higher in the Carpathian Basin than at global level. Here I would like to show you the global map of the possibility of heat-related mortality. And you can see that some parts of the world are at a greater risk. As you can see, the African continent, and also the Asian continent, and South America, and also the Middle American countries. But even the United States and Canada is also potentially affected by this heat-related mortality. And if you look at Europe, the European countries are shown by quite small figures. Here you can see Hungary, which is, we can say, a little bit better positioned than the other countries like Poland. And, but I can call your attention that the risk of dying from heat is quite high also in Finland. So it's quite astonishing for us that in the Scandinavian area, where the mean temperature is much lower than in the middle part or in the southern part of Europe, but the risk of dying due to heat is higher. And this is because people living in each meteorological part of the world are accustomed to a certain level of temperature, and the main impact is related to the change of the temperature, to the very high and very sudden increase of the temperature, which can cause a lot of problems. So the future is not so nice. We should do something in order to reduce this very high risk. And This picture shows us the exposure of vulnerable populations to heat waves. And as you can see, as I mentioned earlier, infants and elderly people are very much exposed. And the exposure and the threat for them is quite high in the European countries, especially in the central part of Europe and the little bit eastern part of Europe, as you can see from the map. So it means that maybe the way of adaptation, the way of preventive measures are not at such a high level in order to reduce this exposure and this risk. This nice figure shows us the temperature-related risk of death during 2015 and 2019. As I hope everybody knows that the temperature and mortality relationship is a G-shape or a U-shape graph. So the cold temperature has an impact on mortality and also the high temperature. And the level of the impact of the cold temperature and high temperature depends on the circumstances, not only on the temperature, but on the circumstances of the heating, the indoor heating, and so on and so on. And as you can see that the greatest risk for the elderly over the age of 80, and the smallest risk is for the working age population, but we should keep in mind that the working age population is also exposed, and the mortality can be traced among the 15 to 64 years old population in each country. The maps of Europe show us the impact of heat waves by countries, and as you can see that there's a very, very high impact in the Mediterranean countries, in the Iberian Peninsula, in Greece and in Italy. And as we go further to the north, the impact is a little bit lower. So here we can see that the countries which act to protect climate change. And as you can see that the level of the different measures, adaptation measures, are quite different. And, perhaps it's quite astonishing for you that the Northern American continent is indicated by brown color, which means that this is very low. So they are not very much prepared for the adaptation. So there's a very very high impact of very high danger that the impacts can be traced and can be met in these countries. And this can be also said about the Asian countries, about Russia, and also the Middle East. And as we can see, some countries in Europe, quite dark color indicates Poland and also Hungary. So it's a picture. This picture was made by independent research organizations, which shows us that there are problems of adaptation in these countries and as well as in Hungary. So here you can see the top severe heat waves in Europe between 1950 and 2023. So we do not speak too much about the heat waves in the previous century. Of course, there were some heat waves, some very severe heat waves, as you can see. There was quite a strong heat wave in 1972, and in some other years in the 20th century. But the most severe heat waves happened after 2010. As you can see, August 2023 and July, August 2010 was a very, very dangerous year. In 2010, the heat wave had the strongest impact in Russia and in the Scandinavian countries. We also very well know the situation in 2003, when the heat wave affected the western part of Europe. It is also indicated in this map. So the distribution is not even. There are some years when the heat waves have a very, very strong impact. This slide shows us that for the summer period of July and September in 2024, as indicated, this was the strongest and warmest season for large parts of the northern hemisphere, like also in Hungary. We suffered quite a lot, and we could see the different direct and indirect impacts of heat waves on the human health. So what were the greatest threats? The increase of transmission of diseases, impacts on health services and facilities. There are a lot of countries where the healthcare system is very much affected by the heat waves and also by the extreme weather events like flooding and storms and so on and so on. Then there were also problems with the disruption of the critical infrastructure and technology. And there were also ecosystem impacts. We can remember the huge wildfires everywhere in Europe, in the different countries, where the air quality suffered a lot, and the long-range transport of PM pollution could be seen in far away from those countries where the wildfire happened. And of course, there were also problems related to the changes in behavior, and including the increased risk of accidents, which could we also saw it in Hungary. I will show you a graph about that. So the direct health impacts are related to the exacerbation of the pre-existing conditions and mental health impacts. So these non-communicable diseases become more serious. A lot of exacerbation can be seen. I can mention respiratory diseases or cardiovascular diseases, problems of blood pressure, and so on and so on. Then the direct, the most severe impact is heat illness and heat stroke. I have to mention that this diagnosis is not so popular in Hungary, so we never hardly find such kind of diagnosis in the mortality descriptions. They are coded as problems of the cardiovascular system and so on and so on. But there were some cases of real heat stroke. But in the Mediterranean countries, in the Middle East, this diagnosis is much often used. Of course, hospitalization is also an outcome of the impact of heat waves, and we face an increased load on the healthcare system because people get worse and worse, their condition is worsening, and they are transmitted to hospitals, and they need some kind of care, and their situation, their health status is so bad that sometimes the outcome is lethal. So that's the problem that we can also detect. The predictions say that the summer temperature increase is related to, is increasing, and some other figures showed the same association. And again, I have to call your attention that after 2010, the steep is much higher, and the association is much stronger. And here you can see the association between temperature and mortality. And as you can see that as the summer temperature increases, the mortality, the temperature-related mortality is also increasing. And after this overview of the global and the European situation, I would like to show you some interesting slides from the situation of Hungary, because as I mentioned that in Hungary the exposure is quite high. The increase of temperature was more than 2.5 degrees of centigrade, as you can see on the slide from the Hungarian Meteorological Service. So it's a real danger for us. And as it was already mentioned, we introduced the three-level heat health warning system in 2005. And since then, heat wave warning is issued every year, with the exception of 2020, when there was no heat wave warning issued, because we had very hot days for 2 days. Then the third day was cooler, and again there was an increase. So it was the variable was very great. But in the other years, the warning was issued 1 to 5 times in a year. And of course, the communication for the general population and also for the healthcare system and social care system is very intensive. And we were very much interested whether this communication, this way of helping adaptation, is really successful or not. And as you can see that there is a slight decrease in the number of excess deaths during the heat alert. In this graph, you can see the number of excess deaths, and you can see that there was a very strong heat wave in 2012 and in 2015, where the impact was very high, and later the excess mortality showed a declining tendency. We also separated the impact of heat waves according to second level of warning, where the cutoff point of warning is the daily mean of 25 degrees of centigrade, and the third level of warning when this cutoff level is 27 degrees of centigrade, and both graphs show us a little decreasing tendency. And as you can see that the excess mortality during the second level of warning is the maximum was around 20%, and concerning the third level of warning, the impact of heat waves is a bit higher. In 2012, the increase was 27% of excess mortality. And it was we also studied that what are the major determinants of heat waves. It is well known that the length and intensity of heat waves play a very, very definite role in causing excess mortality. But we also could detect that in those years when there was a very strong influenza or influenza-like epidemics during the winter time or early springtime, then the excess mortality in the early heat waves was much lower. And later, when the heat wave hit Hungary in July or in August, then the impact was much higher. And the opposite is also true. If there is no intensive influenza epidemics during the winter time, then the first heat wave has a very high impact on excess mortality. So it means that there's a certain amount of vulnerable population, and the vulnerable population health status is affected during the first impact, whether it is influenza or it is heat, and it harvests those who are very, very vulnerable. And the opposite is also true. So, but as I mentioned, not only the elderly and the very ill people die during the heat waves, but those who can survive for months or even years later. So this is a real impact, not only the harvesting effect of the heat stress. this Euromomo is a network which examines the weekly excess mortality in 23 countries of Europe, and this graph shows us the situation of the the previous year, and here you can see the impact of the July heat wave, and this is the August heat wave, and this is already the September when there was a small coronavirus epidemics. So as you can see that it can be traced in the all-cause mortality, weekly all-cause mortality as well. And here you can see the daily excess mortality and the heat waves. The different colors of the columns show us the second level and third level warning. And as you can see that there were some days during the July heat wave when there was a very, very high excess mortality. And as I mentioned, that if it were the so-called harvesting effect, then after the heat wave, there should be a negative, a minus in mortality. Of course, we see some days when the mortality drops because there's a variability, but there's not a long-lasting true negative wave after the heat wave. So this finding supports us that not only the very, very weak and very vulnerable population die during the heat waves. And as you can see, the result, the last summer was quite an extreme summer, because as you can see that the 91 days, which we consider the summer period from the 1st of June to the 21st of August, 41% of the days belong to some heat alert periods, so it's quite high. As it was when we made the first projections, this was thought for the end of this 21st century, and now we are at at the end of the first part of the 21st century, and we already arrived at this level. But altogether, the number of excess deaths was 1,753 excess cases, and as I mentioned, these extreme days in July, where there were 178 excess cases normally. During the summertime, the daily average mortality is 316 cases, and on that day there was an extra 178 excess mortality cases, which as a number is not very high, but if we just sum up the excess lost is quite high. We also introduced the so-called syndromic surveillance system. So we collect, we get the data from the ambulance, the acute cause, the data of the emergency cause, and we also were very much interested what are the reasons for calling the ambulance. And as you can see, there are quite different diagnoses or symptoms. First of all, the blue line shows us the so-called hypoglycemia, dehydration, is a lack of water supply, and also hyponatremia, so lack of sodium, calcium, and so on and so on. Then, of course, there were some causes due to heat stroke and exposure to excessive heat. Dizziness and malaise, they are so-called general complaints. People feel unwell and they call the ambulance due to these problems. But I have to call your attention that there were quite a lot of causes of mental and behavioral disorders, and as it was mentioned also in the IPCC report, the number of accidents increased, and it was very, very visible in the August, during the August heat waves. So we also have to call the attention of the general population in order to be aware of these problems of traffic accidents. So what can we do? Because as it was mentioned that our efforts to reduce the carbon emission will not be very, very effective. So we should do everything for increasing the resilience and increasing the adaptation. So we have a national climate change strategy. The short-term, mid-term, and long-term strategic aims are very good in accordance with international aims, but the problem is that we should implement successfully these kind of strategic aims. Heat health alert system is working, but as I feel, we can still increase the adaptation measures in hospitals and social care system, because there are a lot of problems, and the mortality in hospitals is much higher than mortality out of hospitals or at home. So people who are in a severe situation, they are delivered to the hospitals, but they die in the hospitals. So we analyze the excess mortality. It would be nice if we can do it real time, not with a very 3 to 6 days delay, and this could help us applying the preventive measures. Syndromic surveillance system is also a very good step forward in this direction. Then what I should like to emphasize that we should put a big emphasis on climate change, on the education. So we should educate everybody, so from the kindergarten to the people everywhere. So this is the communication for the population, awareness raising, and also education built in the educational system. And last but not least, we should educate medical students, and also the postgraduate training courses should also contain such kind of knowledge. Then there are some other kinds of systems by which we can evaluate the impact. And of course, we also have to do our ability of the healthcare system, which is also a very great task for us, and we can see quite nice steps forward. So in April, there was the annual meeting of the Association of the Hungarian Hospitals, and there was a competition announced, and around 40 projects were submitted, and the projects were very good. And these hospitals really did quite a lot in order to reduce the impact and to help the resilience of the hospitals. And of course, we should also keep in mind the problems of other indirect impact, and this is one of the impact is the change of the allergenic plants and the pollen season, and we should also teach and inform the population. So we have to reduce the environmental risks. You know, if you think in a global view, we have to reduce also the emission, which can contribute to the CO2 concentration, and also the conventional chemical pollution of the air to increase the quality of the ambient air and also the indoor air. And of course, we have to do everything in order to make our homes, our flats, the working areas more heat resistant. So that is a very, very great task for us to increase heat resilience. And of course, we have to warn the population, inform the population, raise the awareness and education, as I mentioned. This table of the possible ways and tools of adaptation was produced almost 15 years ago in the IPCC third assessment report. So this summarizes the most important steps what we can do, even in those circumstances which are not so favorable for us. So we have to lower the thermal stress. So the building guidelines, building regulations will help it. So, and housing and the planning of buildings using sustainable building materials will help us in this way. Early warning systems should be introduced, which it's already in Hungary. And then we also have to change our cultural behavior, like changing of clothing and changing the regime working time, to discuss about the introduction of siesta. Then, of course, we have to be aware of the extreme weather events. There are some legislative means. I don't want to read everything. Urban planning and storm shelters will help in this way. Air quality, as I mentioned earlier, that we have to control emission and restrict the traffic and use clean fuels for the traffic. But we have heard that this has some kind of limits. Then we have to improve the public transport, and car sharing will be one solution, or using bicycles, or walking on foot, and so on and so on. Then we didn't mention, or mentioned only once, the vector-borne diseases. The vector control is very, very important. Vaccinations should be increased, so new vaccines have to be prepared. There are a lot of diseases where we do not have the vaccines for humans. So there are some vaccines for animals, like for leishmaniasis, but not for humans. Then we have to keep sustainable surveillance of vectors and the rate of infections of vectors, and we have to control the spread of vectors and decrease the number of vectors. Health education is also very important. And of course, waterborne diseases are also very important. And as you can see, that we have to improve the water, the ways of water treatment, filters, and so on and so on. And last but not least, the food security should be increased, and the diseases, the microfungi, diseases of different wheat and maize and other types of other food items should be decreased and should be controlled, because it is also a very, very important increasing threat. Heat health warning system I already mentioned, and last but not least, I have to advertise the result of our Erasmus Plus project. Within the frames of this project, we developed new curriculum for graduate and postgraduate medical training, and the teaching material is now available in different languages, in English, Hungarian, Romanian, and Serbian language on our webpage, and it's freely available, so I can encourage everybody who is interested to read it or to use it in the graduate and postgraduate education. What is this teaching material about? I only would like to show you quite quickly some slides. So we discuss the baseline elements of heat, thermal homeostasis, heat stress, and responses, the impact of heat on the whole organism and the cardiovascular system, the impact of heat stress on mental diseases, as I already showed you that during the heat waves, this mental complaints increases, and some other impact on cancer, impact of renal diseases, and so on are also available in this teaching material. So by this, I would like to thank you for your attention, and I hope that I could give you some kind of useful information for your future work. Thanks.
Thank you for your presentation, and I offer, because of the time schedule, for you to take your question to the professor in the coffee break. And before we would go out, I just give the word to my colleague.
As usual, technical information, very important technical information. We are in a little delay, as you experienced. No problem, this will make the coffee break longer, of course. Coffee break is an important thing. And it is downstairs at the poster session area. But you will be stopped on the stairs. Because, as you could see, we have now a photographer. So we will make the conference photo now in the coffee break in the staircase. You will be stopped there, you will be not able to go to the coffee